The objective of this lesson is to convert measurement units within the same system using ratio reasoning. In 4th and 5th grades, students solved measurement conversions by creating diagrams, tables of equivalent measures, or by solving multiplication and division problems. Students will now apply ratio reasoning as discussed in this chapter to solve conversion problems as well. Let's look at a problem that can be solved using ratio reasoning. How many feet are in 72 inches? Students should recognize that the ratio of feet to inches is a 1 to 12 relationship, or 1/12 of a foot for every 1 inch, and the ratio of inches to feet is 12 to 1, or 12 inches per every 1 foot. Using a double number line where inches are represented on the top and feet are represented on the bottom, we can represent equivalent ratios of 12 to 1 as we determine how many sets of 12 would be needed for 2 feet, 3 feet, and so on up to 6 feet. From the double number line, we can see that there would be 6 feet in 72 inches. Another way to find a solution to this problem would be to create a table of equivalent ratios. As with the double number line, this table organizes equivalent ratios for 1 to 12, increasing until a ratio can be found that shows how many feet are in 72 inches. Additionally, a condensed ratio table could be used to determine the answer. The relationship between 12 inches and 1 foot was found by dividing 12 by 12 to get 1 foot. Then the same relationship can be found for 72 inches by dividing it by 12 to get 6 feet. The answer is there are 6 feet in 72 inches. Let's look at a real-world problem using fractional ratios. Megan is making an Alfredo sauce for a dinner party. Unfortunately, she can't find her measuring cups, so she used a tablespoon to measure out the heavy cream needed for the recipe. Megan used 28 tablespoons of heavy cream. How many cups did she use? Remember, there are 16 tablespoons per 1 cup. With a double number line, we can make equivalent ratios for 16 to 1, showing tablespoons on top and cups on the bottom. We quickly notice that the next natural equivalent ratio of 16 to 1 is 32 to 2. This is greater than 28 and too large of a number for the amount that Megan used. We need to make some fractional portions between 1 and 2 cups. What if we divide between 1 and 2 cups in half? Notice that 24 tablespoons is not enough. We need to find 28 tablespoons. We can divide the space between 1 cup and 2 cups into fourths. We also divide the space between 16 tablespoons and 32 tablespoons into fourths. The equivalent ratios for these sections will be 20 to 1 and 1/4, 24 to 1 and 1/2, and 28 to 1 and 3/4. The solution for 28 tablespoons is Megan used 1 and 3/4 cups. This solution can also be found using a ratio table. For every 16 tablespoons, she used 1 cup. This relationship was found by dividing 16 by 16 to get 1 cup. An equivalent relationship would be found by dividing 28 by 16 to get 1 and 3/4 cups. Let's look at an example of a problem that must be converted twice to find the solution. The students in Ms. Parker's PE class ran 8 laps around the school's soccer field. Each lap is 330 yards. How many miles will the class run? We must first find out how many total yards are run in 8 laps. We can make a ratio table to show an equivalent ratio for 1 to 330. The relationship between 1 and 330 can be found by multiplying 1 times 330. So the relationship between 8 laps and the unknown total yards can be found by multiplying 8 laps times 330 to equal 2,640 yards. Next, we must convert 2,640 yards into miles. A second ratio table can be made that sets up the comparison of yards to miles. We know that there are 1,760 yards per 1 mile. This relationship can be found by dividing 1,760 by 1,760. Likewise, we will divide 2,640 by 1,760 to find 1 5/10 miles, or 1 1/2 mile. The objective for this lesson was to convert measurement units within the same system using ratio reasoning. We met this objective by showing how to use a double number line or ratio tables to convert units of measurement.